Welcome to the Simpson Strong Tie Anchor Systems Testing Lab in Addison, Illinois. Our anchor systems are basically products that fasten one material to another. Everything from mechanical anchors to adhesive anchors, powder actuated fasteners. Our product lines actually also include the carbide drill bits that are used to drill holes to install those products. We're looking at trying to understand how the anchors influence each other, what their performance is like when anchors are spaced close together, what the performance is like when they're spaced near edges, how the anchors perform over the long term, how the anchors might perform in some adverse conditions. For example, if you're installing an adhesive anchor into a damp hole or a water-filled hole, will that adhesive anchor still hold? When people come to the Addison lab, I think the thing that they're most impressed by is not so much the actual testing we do, but the scope of the testing. This is one of our moving crack test setups. This is a setup or a piece of equipment that we designed and built in-house. The purpose of the test is to simulate the opening and closing of a crack that might occur in a reinforced concrete beam. So what we have here is a concrete block. We've initiated two cracks which are running in line with these anchors over here. The anchors are installed into the crack, and what we're doing is start cycling the crack open and closed while the anchors are subjected to a sustained tension load. And the idea is we want to measure the displacement of the anchor to make sure that the displacement doesn't exceed a specified amount over the running of the test, over 1,000 cycles. And after we run the test, we're going to be doing a residual test, which is to pull the anchor to failure and make sure that, and find out if it's lost any capacity as a result of being subjected to this opening and closing of the cracks. This is our creep test. This is a test that's designed or it's used on adhesive anchors. Some adhesive products can slip over time or exhibit displacement, deformation over time. And that's something that we want to control and hold at a minimum. So the next step is these guys are going to torque up on this, on the equipment over here to apply the correct sustained load. What we're doing is we're measuring the displacement, the vertical displacement of the anchor. This block has already been conditioned to an elevated temperature. After the sustained load is applied, we're going to take the block and put it in an oven, and we're going to hold the entire block and assembly at an elevated temperature for an extended period of time. We also extrapolate out that performance to look at longer terms to make sure that the slip is attenuating over time, so that basically it's an indication that the anchor will slip a little bit, but it will then stop, and it won't be a problem in the field for the years and years that this anchor will be in service. This is our seismic tension test equipment, and what we use this test for is to subject an anchor to a cyclical load that is meant to simulate a seismic event. We're going to be running the test in a crack. We have the anchor that's attached to our seismic actuator here that's going to produce the up and down motion, the cyclical motion to simulate that earthquake result. And we have instrumentation going across the crack to monitor the crack width as the test is conducted. Within the actuator itself is also equipment that monitors the amount of load applied to the anchor and the amount of displacement that the anchor is seeing as a result of the test. Just looking at this laboratory, we've made a tremendous investment both in the people and the equipment in this laboratory to be able to do our own product development in-house, to do our own testing in-house when it's permitted. And I think that gives Simpson an advantage in terms of research and development efforts, and it ultimately results in better products to the end user.